Right. IUPAC nomenclature. So International Union of Pure and Applied Mathematics, that's IUPAC, brings out a systematic way of naming compounds which is more accurate than trivial names. Now normal we have like hydrogen sulfide, potassium ferrocyanide we have. These are trivial names. These are not real names. These are not real names. These are trivial names. You call these trivial names. So we are using something like a systematic way in order to name inorganic compounds. Now there is a reason why I did inorganic nomenclature at the end. This nomenclature, naming inorganic compounds, I did at the end. You can understand, right? You have done inorganic and you have stayed with inorganic for a long amount of time. And now you just have to name those compounds, right? Naming those compounds that we are going to do it now. After learning all the reactions and colors and everything, now at last we can name those compounds because now we are familiar with those compounds. Same like organic nomenclature. Inorganic nomenclature also should be done at last. So there are 4 ways of formation of a compound. Now I'm talking about ionic compounds, nomenclature of ionic compounds. So under that there are 4 subtopics: simple cation and simple anion compounds. For example, write an example there: sodium chloride. Right, sodium chloride. Then there is the simple cation and complex anion. For example, sodium CuCl4, NaCuCl4, Na2 actually, Na2CuCl4. So simple cation and a complex anion. Complex anion කියන්නේ ligands coordinated to a D block element and then you put it inside a bracket and then you have a complex anion. Then third one, you have a complex cation and simple anion. For example, something like this: copper, ammonia, 4, Cl2. There you go. So this is a complex cation and a simple anion. And then finally, complex cation and complex anion. You can have both of them together. For example, copper, ammonia, 4, and then it will join with CuCl4. There you go. Hari. So this is the cation part. This is the anion part. Complex cation and complex anion. Write this in small letters, right? Hari. Now elements that form cations belong to simple cations and they get their trivial name. For example, you have sodium, which forms sodium plus cation, and there is potassium, so it gets the normal name that it has. There is calcium, calcium 2 plus. Hydrogen also same, hydrogen forms hydrogen plus. The name given for these are just, sodium, potassium, calcium, hydrogen. That's it. If you have zinc, then zinc. Right, zinc. However, there are cations which form more than one cation also belong to simple cations. We have to understand them clearly. Now, there are some atoms which form more than one cation. For example, Fe2 plus, Fe3 plus, lead 2 plus, lead 4 plus, right? Mercury plus 1 and mercury plus 2. And then there is SN2 plus and SN4 plus, and there is Cu plus and Cu2 plus. So there are different versions of the cations that are formed by different atoms. For example, Fe forms Fe2 plus, Fe3 plus. Lead forms lead 2 plus and lead 4 plus. And copper forms copper 2 plus and copper plus. I will write copper plus on top and copper 2 plus on the bottom. And then there is mercury, Hg plus and Hg2 plus. Right, so tin tin 2 plus, tin 4 plus. Hari. Fe2 plus, you give a name iron 2. Iron 2. Easy, right? Iron 2. This is iron 3. This is not lead, plumbus. We can call it plumbus. That's the other name we can go now for iron. Also, we can call ferrous. Make it ferrous. We can call it as ferrous. And this is ferric. This is another name which can be given, right? Which can be given, but I prefer you writing like this iron 3. For example, FeSO4, you can write iron 2 sulfate. I will tell that later, combining anions and cations and writing. This one will be lead 2. This one will be lead 2. This is lead 4. And this is plumbus. This is plumbic. This is copper. Copper 1. This is copper 2. Copper 1, copper 2. And the other name you can give is cuprous, cupric. This one, mercury 1 and mercury 2. Mercury 1, mercury 2. This is tin 2, tin 4. This is called mercurous. This is mercuris. It's like Hercules. That is right. Tin 2 plus, you have stannous. You don't know who's Hercules, right? Do you? Do you know who's Hercules? Which year you were born in? 2008. Yeah, Hercules is a Greek god. There's a game for Hercules. I played it when I was small. Yeah, cartoon guy. There's a man. That's a man with a body of a horse and a top part of a man. So I don't know whether it's a horse or a man, but yeah, it's combination of those two. Tin 4 can be called stannic. Okay. Polyatomic cations formed by combination of one or more elements as shown below also fall under simple cations. For example, NH4 plus, NH4 plus, H3O plus, CH3NH3 plus, then CH3CH2NH3 plus, and you can go on like that. So NH4 plus, ammonium, ammonium sulfate, you have heard that, right? This is hydronium. In some books, they tell like hydrosonium also. Methyl ammonium. And this is ethyl ammonium. You have to write them together. Can write these things. Lamai, then you have simple anions. Okay, write these things quickly. Hurry. Simple anions, monoatomic anions end their names with "ite." Oxide, nitride, sulfide, fluoride, bromide, iodide, and write some examples. O2 minus, N3 minus, S2 minus, F minus, Br minus, I minus, oxide, nitride, sulfide, fluoride, bromide, iodide. There you go. If an element have two anions, name of the anion with the low oxidation state ends with "ite" and the other ends with "ate." Sulfite, sulfate, nitrite, nitrate. Write the examples. SO3 2 minus. Sulfite, SO4 2 minus. Sulfate. NO2 minus, NO3 minus. Nitrite, nitrate. What else do we have? That's it, right? Nitrite, nitrate. Yeah, HSO3 minus also we can include here. HSO3 minus, HSO4 minus. This is hydrogen sulfate. Hydrogen sulfate, hydrogen sulfite. I always get confused with oxide, peroxide, and superoxide. Okay, you attended my class, right? I mean, why are you getting confused? I will teach you. Oxide means you have the central, like single oxygen, and there are 8 electron pairs around it, which will give you a 2 minus charge. That is the oxide. What is peroxide? This is sulfite, sorry, other way. Sulfite and sulfate. Okay, you have O2 minus, and then you have 2 oxygens in now peroxide I'm talking about. In peroxide, both the oxygens have negative charges. Both the oxygen have negative charges, right? So for example, oxide compound, sodium oxide, Na2O. You need 2 sodiums in order to neutralize 1 oxygen. And for peroxide, you can have Na2O2 because this one contains 1 negative charge and the other one contains the other negative charge. So it's going to be 2 minus overall. So you need 2 sodiums in order to neutralize it. Now superoxide contains 2 oxygens, but 1 oxygen has an odd electron. There's an odd electron species containing compound superoxide, but the other oxygen has a negative charge, like this. So you call this superoxide. You call this superoxide, and the formula you can write NaO2. No, sorry, sodium doesn't form KO2. Right, KO2. Do you get it? Yes. Now understood, right? Do not forget it. It's a very important part. I mean, it's a basic part. Do not forget it. Hurry. So sulfide, sulfate, nitrate, nitrate, hydrogen sulfide, hydrogen sulfate. Right. Next on, some polyatomic anions contain unique names. What are they? HS minus. Now this one is easy. Hydrogen. Hydrogen sulfide. Hydrogen sulfide. Thiosulfate is 2O32 minus. Thiosulfate. Thiosulfate is 4O62 minus. Tetrathionate. SCN minus. Thiocyanate. Thiocyanate. Right, thiocyanate. NH2 minus. Amide. CN minus. Cyanide. That's it, right? Yeah, that's it. Write this down. Then the next one, if oxygen atom is okay. Now thiocyanate, thiosulfate, I should have included here, but it's fine. You can write it here also. Now SO42 minus you have SO42 minus. If you remove an oxygen, what happens? If you remove an oxygen and add a sulfur, okay, you have to add the sulfur and remove an oxygen. You get S2O32 minus. Now this is sulfate. This is thiosulfate. OCN minus. OCN minus is cyanate. So when you add a sulfur and remove an oxygen, you get SCN minus. You call it thiocyanate. Cyanate, thiocyanate. So we react the thiosulfate with iodine. For that reaction, there is a name, right? Iodometric titration. That's the iodometric titration. So there's something which you don't know, like you're not learning in A levels. There is iodometric and iodimetric. There is iodometric and there is iodimetric. Iodometric is like you are going to prepare the sulfur and then you're going to titrate. Right? Iodine. Prepare the iodine. What am I writing? Prepare the iodine. Prepare iodine and then only titrate. Iodimetric, you are titrating with already made iodine. Already made I2. Right? So iodometric, if you ever hear something like iodimetric, if someone asks you what's that, you can tell this. I don't think you have it for your A levels. It's not in the resource book. Okay, so some hydroxy complexes can be written in their short form. Now, lamai me chlorine containing compounds. Can you remember I told you hyperchlorite, chloride, chlorate, perchlorate kila mangwar given is. Can you remember that? Now, there's Cl minus. Cl minus, all of you know it's going to be chloride. Cl minus is chloride, lazy. Then ClO minus is there. Then ClO2 minus is there. ClO3 minus is there. ClO4 minus is there. Now, I told you ClO2 minus, you have to write it as chlorite, and this is chlorate. That is easy. Every one of you know that. Chlorite and chlorate. Higher oxidation number is going to be chlorate. Low oxidation number is going to be chlorite. Now, what do you call low blood pressure? What is the name given for low blood pressure in biology? Hypotension, right? Every one of you have answered it. You call it hypotension. So here also same thing. When you have a low oxidation number, you call it hypochlorite. Hypochlorite. Now, when the oxidation number increases, now what do you call as high blood pressure? What is high blood pressure? What is high blood pressure? Hypertension, right? But you don't write hyperchlorite. You don't write like that. You write perchlorite. Right? Perchlorate, sorry. Perchlorate only what you're writing. You cut the high part. I don't know why, but that's how it is. Perchlorate. Perchlorate. That's the chlorine containing compounds. Phosphorus containing compounds, so you have P3 minus phosphide. PO4 3 minus phosphate. HPO4 2 minus hydrogen phosphate. You leave a space there, hydrogen phosphate. H2PO4 minus dihydrogen phosphate. Dihydrogen phosphate. Identify the IUPAC name of the following ionic compounds formed. Simple cation with simple anion. Now you have to identify them. There are two more you have to write. Lamai. You need to paste something or somewhere and then write it, because there are two more. You have to write. I think I'm going to condense this and write. You can write it in a separate A4 sheet and then you can paste it there. Now, since some of you are writing in A4 sheets, you can just adjust it and write it below. There are two more I need to write. Now, this is chlorine containing. This is phosphorus containing. And next one is oxygen containing. Here, the acidity of chlorine increases with increasing number of oxygen. No, you don't take it like that. Acidity increases with increasing oxidation number. That's how you take it. Will you be doing the ligand section from that tube today? No, I have already completed it. I told you, right? So you can watch the recording now. If you want the ligand section, I will be sending the recording free for you. You can text me in WhatsApp. Because this is the last few days to the exam. I don't want any of you to go to the exam without a theory part. If you have any issues, I mean my students who have enrolled with the class, I don't want you to miss anything from theory. If you have anything you need to complete, you can let me know. not units. Don't tell me I want energetics. එහෙම දෙන්නේ නැහැ. හරිද? For some like small part, maybe like if you don't know, I can give you that section only. හරිද? එතකොට ඔක්කොම ටික ඉල්ලන්න එපා. Like I want full energetics for free. එහෙම දෙන්නේ නැහැ. හරිද? It's going to be a disadvantage for the other students who have paid and joined. So if you want a very small section like පොඩි කැලලක් දැන් හිතන්නකො isomerism. හරිද? ඔය වගේ පොඩි දෙයක් ඕන නම් කියන්න, like I will be giving you for free. හරි. So carbon containing carbonate, hydrogen carbonate, HCO3 minus, hydrogen carbonate, and then oxalate, C2O42 minus, and then hydrogen oxalate. Hydrogen oxalate. And then finally, you have oxygen containing compounds, O2 minus oxide, OH minus hydroxide, and O2 2 minus peroxide, and then O2 minus superoxide. Now you have to identify the name. So before that, you have to write another section. I know I haven't left any space for it. It's my fault. You have to write something else also. There's a small part you need to write. So I will write it here. You can Tipex this off if you don't have any space there. AlO2 minus. You call it aluminate. Aluminate. PbO2 2 minus. You call it plumbate. Let me put simple letters. Aluminate, plumbate, SnO2 2 minus, stannate. And then next you have ZnO2 2 minus, zincate. Stannite is also there. Then make him, stannite, SnO3 2 minus. Sorry, ඒක stannate, අරක stannite. මේක stannite, this is stannate. 8 large oxidation number, you call it 8. So write these 5 also. So write this. නෑ තව ටිකක් තියෙනවා ලියන්න. There are 4 more. අර මට බොටවට එනවා ළමයි මේ to my head. හරිද? Chromate, you also have to write chromate. Cr2O72 minus dichromate. Now these are things which you see in your A-level syllabus. තව එළියට ඇති තව තියෙනවා. There are more to write, but we don't write them. MnO4 minus permanganate. And then MnO4 2 minus manganate. හරි ඉච්චරයි that's all don't worry. To identify names of ionic compounds formed by simple cation and simple anion, like how many examples will you give? Just to write under it these examples. Around 10. Now the ligands, both videos I'll be sending to our groups. It's not for 2027 students. 2027 I'll be doing for you. I will do it separately. This is for 2026 students. I'm sending the recording. Okay, sure. I'm going to faint. Okay, sure. Both the ligands recording I have sent to the group. Hari lamai. Then I will give you some examples to write. First one, CuSO4, easy. Second one, CuClO3 twice. Third one, NiCO3. Fourth one, K2MnO4. Fifth one, CaC2O4. Sixth one, Na2HPO4. No, sorry, NaHPO4. Na2HPO4. Na2HPO4, and then seventh one, LiHC2O4. NaAlO2. Ninth one, 10th one. 10 examples enough, huh? I will give you NaNH2, KNO2. Hurry, KNO2. Write the names of this. What time the class ends? We started at 7, right? 8, 9, 9:30. Around 9:30. We have to do it quickly. Copper 2 sulfate would fit the first one. Thank you, plus sulfate. I will write copper 2 sulfate. Copper 2 you have to write together, and then sulfate, leave a space and then write sulfate. This one, copper 2. What is the ClO3 minus? ClO3 minus is what? Chlorate, right? Chlorate. ClO4 2 minus ClO4 minus is going to be chlorate. So this is going to be chlorate. Copper 2 chlorate. Nickel carbonate. Nickel 2 carbonate actually. Nickel 2. It's not a capital letter. Simple, everything simple. Nickel 2 carbonate. This is potassium manganate. Potassium manganate. This is calcium oxalate. This is sodium hydrogen phosphate. Give me a second, Lamai. Okay. Seventh one, lithium hydrogen carbonate, oxalate. Lithium hydrogen oxalate. Lithium hydrogen oxalate. This is sodium aluminate. Then ninth one, sodium amide. And then this one, potassium nitrite. Next month, 10th will hit different. Yeah. You also have exams, right? I also have exams. August 15th I have. First semester exam. So we also have different subjects. You know what we have as subjects? We have zoology exam, chemistry. We have plant science, computer science. We have applied mathematics, we call AIM. Applied mathematics for BA students, so that exam is there. And also calculations in chemistry. It's an elective course I have selected, calculations in chemistry. And yeah, these are the things. Okay, then we are going on to the next one, complex cation. When naming complex compounds, we have to name the cation first and anion second as usual. Within a complex ion, ligands are named first in the alphabetical order and metal ion is named at last. The names of anionic ligands end with O, whereas neutral ligands usually called by the name of the molecule. Exceptions are H2O, which is aqua, and carbonyl, carbon monoxide, and ammonia, amine. When several ligands of a particular kind are present, we use di, tri, tetra, penta, and hexa to name them. Fourth one, oxidation number of the metal is written in Roman numbers following the name of the metal cation. Given below are names of ligands used in inorganic. So please write these examples. Neutral ligands. Neutral ligands. Now what are ligands? Ligands are compounds which are attaching to the central metal cation through dative bonds. For example, copper 2 plus. Ammonia is a ligand. Ammonia attaches to copper by forming a dative bond like this. So ammonia acts as a ligand. That's a ligand. Right? So neutral ligands examples are water, ammonia, and then carbon monoxide. So H2O, you call it aqua. This is amine. Sorry, amino, not amine. Amine is like for me organic. For organic, this is amino. Wait. Amino, amine. Sorry, other way. Amine. Carbon monoxide is going to be carbonyl. Negative. So negative ligand, Cl minus, Br minus, I minus, those things are there. You can just write chlorido. Chlorido. H minus, hydrido. OH minus, hydroxido. Br minus, bromido, I minus, iodido. You can write that, right? It's just like Cl minus. Br minus, I minus, yeah, fine. So SO42 minus, sulfato. And O2 minus, oxido. Cn minus, cyanido. Now, if you find more examples, we'll include while answering questions and all. We'll include them. Okay. Thiocyanado. Write this down. There are no positively charged ligands. එන්නෝත්දාමකු. Okay, then next one. We have to complete this note by ourselves. Hari. Okay, so when there are two or more ligands coordinated, we use the plural form of this. Now I will condense this a little bit to the side and write that table on the right hand side. We use prefixes. If there are two, we use di. If there are three, we use tri. If there are four, we use tetra. If there are five, we use penta. If there are six, we use hexa. Okay, then first example I'll give you. Through examples only we can practice this. So let's say we have copper with 4 ammonia and the total charge is +2. So we are naming complex cations. We are naming complex cations. So copper, ammonia 4, 2 plus. How are we going to name it? First of all, there are 4 ammonia molecules. There are 4 ammonia molecules in the compound. So we can write tetra tetra, and though you don't combine the letters together, you just write tetra amine. Don't leave any space. There's no space here. Tetraamine, copper, all together. Don't leave any space. No space. Tetraamine, copper, 2, copper 2, and you leave a space and then write iron. You leave a space and then write iron, okay? Tetraamine, copper 2, iron. Second one, nickel, ammonia, 2, H2O, 4, 2 plus. What about this? Now we have amine and then you have aqua. You write it separately on the side. Amine you have, aqua you have. Now you have to write it in the alphabetical order. Look at the first letter, both letters A, right? So we go to the second letter. Second letter is M for amine and Q for aqua. So you need to know the alphabet. Can you repeat the alphabet, Lamai? Hi, A, B, C. You know, right? You don't know the alphabet. Raise your hands if you don't know the alphabet. Raise your hands if you don't know the alphabet, Lamai. Anyone? Anyone who don't know the alphabet here? Anyone who don't know the alphabet here, right? You know the alphabet, right? So M comes first. M comes first. Hari? Okay. So amine comes first. So diamine. Diamine, tetra. Yes, very good, Sachini. That's correct. Tetra aqua. Nickel, 2. Iron. Right? Nickel, 2, iron. There you go. Then third example. Let's say you have cobalt, ammonia, 4, OH2 plus. How about this? Now there is hydroxido and there is amine. There is hydroxido and there is amine. So first of all, you have to write amine. Tetraamine, dihydroxy, cobalt. And what's the oxidation number of the central atom? What's the oxidation number of the central atom? Oxidation number of the central atom is going to be +3, right? If this is +3, this is -2 altogether. So altogether, the overall charge is going to be +1. So the central atom should be +3 oxidation state. So you can write tetraamine dihydroxy. Wait, not dihydroxy, dihydroxido. Sorry. Dihydroxido, cobalt, 3. Cobalt 3 iron. No spaces until the last place. Okay. Until you write iron, there is no spaces in between. Tetraamine dihydroxido, cobalt 3 iron. Yes. Fourth one. Name this alone. Name this alone. Okay, first of all, now you have to identify this is cyanido. Cyanido. This is hydroxido. This is aqua. This is amine. So when you're naming it, you start off with AM, right? AM comes first. Diamine, diamine, diaqua, diamine, diaqua, cyanido, cyanido, and then hydroxido. Nickel, diamine, diaqua, cyanido, hydroxido, nickel. What is the oxidation number of nickel? +2, right? OH minus is there. Altogether, there's a plus charge on the compound. I forgot to write it. No, there is no plus charge. We just write nickel 2. There's no plus charge. Nickel 2. There's no iron part here. Then the iron part is done. We just end it with nickel 2. These names feel like Harry Potter. Why is that? Nickel 2. Now Rifana, you can't use Roman. I mean Arabic letters you can't use. You can't use like this. You have to use like this. Roman numbers only have to use. We are writing within brackets. It's not compulsory. Your keyboard doesn't have Roman. You can use I. Yo, Rifana. Capital I. You don't have capital I in your keyboard? We all don't have Roman numbers in our keyboard. That is how you type Roman numbers. It's the letter V and I, number 4. Number 5 is V. Now V and I is number 6. X is number 10. X and I is number 11. Right? Any one of us don't have Roman numbers in our phone, but we have the alphabet. Right. Okay. Still wrong. It is 1-1. Umaira, I have it written 1-1. It's I. Capital I, capital I. That's how you use. Yes, alphabets and Roman. Yeah. Fifth one. Now the example. Let's say we have Fe. Fe won't form ammonia complex. Now write the name of this. Can you show the upper page? Okay. Yeah, complex anion is on the next page. I gave anions. Now, 2 questions can both of them. Make anion. This is not an anion. This is an anion. That's my fault. Wait. My fault. H2O 4Cl2. Sorry. Alright. First of all, here you start off with aqua, right? Tetra aqua, dichlorido, iron 3, iron. Iron 3, iron. Okay. Iron 3, iron. Okay, then here triaqua, trithiocyanato, iron 3. Yeah. It's thiocyanate, it's not cyanide. We are not using ferrous, Sashini. We are not using ferrous. We are not using ferrous. When you're naming anionic ligands, we are using ferrate. That's a different story. I'll tell you that. Seventh one, the last, I'll give 10 examples. 9, 10. Let's say you have I will give the other three. I will give the other three to the other direction. I'll give you the name. You have to convert it to the compound. Hurry. Triamine, aqua, chlorido, hydroxido, cobalt 3 iron. aqua, chlorido, hydroxido, chlorido, hydroxido, iodido. Okay, I'm giving you a compound. You have to write the formula. Give me a second. I need to think now. It's all in my head. I'm writing. I will put. If I put 2 aqua, 2, 3, 4, 5. Try. Try aqua, chlorido, hydroxido, iodido. Try aqua, chlorido, hydroxido, iodido. Iron 3. So you can write the ligands in any order. Now in A levels, they don't check that. In which order are you writing? They don't check that. Hurry. 10th one, you have to write the name of write the name of this compound last. Now 8th on triamine. Triamine kyanne there is 3 ammonia. Aqua is there. Chloride is there. Hydroxide is there. And cobalt 3 is there. So plus 3, minus and minus, so plus 1. This is iron. Triaqua, 3 water. Chloride is there, hydroxide is there, iodide is there. And there is no iron here because all the charges are neutralized. In this example, sulfato. This is sulfato. So it's penta, aqua, sulfato, copper, 2. It's no iron there. Right? That's it. Then you have complex anions. Rules for naming complex anion. Ligands are named as named first as usual with the prefix. Or isella game like before we are using the prefix. The only difference that the metal ends with 8. Now if you have a metal, you're going to end it with 8. Now in this example, you are just writing iron. This is cobalt. This is what? Iron again. And this is nickel. This is cobalt, nickel, copper. You are writing it like that. But here we write we end the metal with 8. It's like chromate, cuprate, manganate, argentate, orate, cobaltate, ferrate, nickelate, mercurate. Right? We have 8 at the end. I need to do 7th one? Sorry. So this one starts with amine, diamine, tetra, aqua, chromium, 3, iron. Hurry. Complex anion. Rules for naming complex anions. Now here you have to write these metals. Chromium, you write chromate. Copper, cuprate. Manganate. Fe, ferrate. Orate. Argentate, not Argentina. Argentate. Ferrate I wrote, right? Cobaltate. Edge is mercurate. Yeah, that's it. Chromium chromate, copper cuprate, manganese manganate, iron ferrate, gold orate, silver argentate, cobaltate, Ag mercurate. And then finally, 3F, your fate. No, it's not a demotivation. Okay, I just told you it's a joke. 3F, 3A is your fate. Your organic QBT cover page changed colors. I think the green color is over in the printer and it's printing in blue color. So some of you people, only like 2 people will receive a blue color organic tute. There are still few sets of tutes to be sent. Hari Lamai. So we'll write examples. First one, CuCl4 2 minus. Second one, chromium OH 4 sulfate minus. So first one will look at you. This is tetrachlorido cuprate. Cuprate 2. And finally you add iron. Cuprate 2 iron. Second one has only 5 against. यानी OH5 kilo na. So what is the answer for this? Now you start off with hydroxido. Pentahydroxido sulfato Pentahydroxido, sulfato, uh, chromate, chromate 3 iron. The charge is also changing. Yeah, that's correct. This is 2 minus. 2 minus නෙමෙයි එතන charge එක වැඩි නේ because sulfate will also have a charge නේ. So altogether minus 2 and minus 5 is minus 7. Minus 7 minus 3 is 4. Minus 4. Can't be assigned any other name other than Argentate. Why Argentina you don't like? Why you're angry with Messi? So you're Ronaldo, right? Okay. But I think Ronaldo is better than Messi anyways. Now, when everyone talks like they're talking about Ronaldo, like like if you don't know football, ask a person who don't know football about Ronaldo, like he'll know it. Like actually, like whole world knows. So Messi is like who coming after Ronaldo, like Ronaldo, Messi, and Neymar. Like after that only you get Neymar third. Me also, like I didn't know about football, and I knew Ronaldo anyways. Like even if I don't know football, I knew Ronaldo. Like it's like going very famous. Okay, do you know that Ronaldo once upon a time there was a conference and there was a Coca-Cola bottle on the table and he just removed it from the table and he just drank water and because of that Coca-Cola sales dropped by a huge amount. So that's the effect. Yeah. So the third one, I will give you this compound nickel. Four chlorine, so it's 2 minus. Write the name for this. Fourth one, cobalt Cl4, NH3 twice, zinc OH4, zinc OH6 down, minus 4, 4 minus, zinc, write the names of this. In the second one, isn't it 4? Nah, it's 3, chromium plus 3, right? Chromium is plus 3. Fourth one has a charge. Yes, fourth one has a charge. Sorry. Cobalt plus 3. So it's minus here. Yeah. Third one, what's the answer now? Diaqua tetrachlorido nickelate to iron. Now, Lama, you write nickelate, chromate, cuprate only if there's a negative charge for the anion. Now, when you have a neutral ligand, for example, like this, you can't consider it as negative and write cuprate. You just write the cationic one. Right? So you write the cationic one when you have a neutral ligand. So for negatively charged ligands, only you're using nickelate, chromate, cuprate, and stuff. For this one, fourth one, diamine tetrachlorido, not chloro. There is a famous mistake which some students do. They are writing chlorido. Sorry, they are writing chloro. Chloro is the oldest method. Now we don't use chloro. We write chlorido. Tetrachlorido, cobaltate 3 ion. Then this is hexa hydroxido zincate 2 ion. This is triamine trihydroxido zincate 2 ion. Then next one, tetra thiocyaneto. Tetra-thiocyaneto diaqua ferrate. I haven't given a charge, right? It's -2. Ferrate 2 ion. Write these things. Amine 6. Which one? Which one is amine 6? Yeah, sixth one amine, not triamine. Amine. Ethana, I think I have to put 3 here because that's a mistake there. You can't have. No, you can have 4, ne? No, you can't. Zinc hydroxide is 6 OH, right? You can't. So triamine. Tetrathiocyaneto diaqua ferrate 2. Yeah, I have changed the question. Now it's strike. Seventh one, aqua comes first, of course. I just checked whether you will notice it. I just checked whether you will notice it. You are good. Hurry. Diaqua. Diaqua. Tetra. Thiocyaneto. Ferrate 2 ion. Talib is not my friend. I just met him in a group. I mean, we got friends later. Okay, complex compound. Now we're going to combine the anion and cation together. Anion and cation together. First one, K3 FeCN6. So this is potassium ferrocyanide. Sorry, ferrocyanide. No, ferricyanide. Potassium ferricyanide. Here you're not writing it like that. You're writing in IUPAC method. First of all, you're writing potassium, right? Potassium, and you leave a space. Cation and anion, you leave a space. Potassium hexacyanido, hexacyanido ferrate 3. Hari, hexacyanido ferrate 3. Second one, copper ammonia 4 sulfate. Write this alone. So Lama, here, first of all, you start with tetraamine copper 2 sulfate. Tetraamine copper 2 sulfate. Third one. Copper for ammonia and CuCl4. Now try this. Potassium letters are 1T and 2S. That's correct. Potassium. Yeah, ඒකත් බලනවා. Like if you write that wrong, you're not going to get marks. Huh? Potassium 1T and 2S. Right. So in this case, tetraamine copper 2 tetrachlorido cuprate 2. Sorry. Fourth one. Copper H2O6 FeCN4 OH2 twice. Now the overall charge of this one would be +2, right? Overall charge of this one would be how much? -4 and -6. -6 and this is going to be 3. It's -3. right? It's -3. So you overlap the charges to get the valencies 3 and 2, right? You get the valencies 3 and 2 there. Write the name for this. Write the name for this. Yes, one small mistake and the whole thing is wrong. Okay, Lamai. So here we don't care about this number. We don't care about the number which is at the bottom. We just name the cation and the anion. So we write hexa, aqua, copper 2, tetra cyanido, tetracyanido dihydroxy. There is no space. Ferrate 3. That's the name of the compound. Dihydroxido. Yes, I told it with my mouth, but I didn't write it. Ne? Hydroxido. Now I'm going to give you the compound of the year. Presenting you the compound cobalt ammonia to H2O 4 Cl. Wait, Cl if I put 2, it's going to be fine, right? 4, 5, 6. No, 1 chlorine. Yeah, so that's going to be +1. That's going to form a compound with this guy. Fe is coming as 7, eh? 4, 5, 6, 7, eh? Yeah. So I'll put 3 here. So Fe H2O ammonia CO I'll put iodine here. So this is the last compound we are going to name. First metal we don't end with it. No. Cation we don't end with it. Yeah, compound of the year. Name it. Okay, there's a problem here. Here it should be 2. Harida, metan 2 window ni. Okay, others are fine ni. 2 minus 1. Okay, right. Now it's fine. Valence ratios 1 and 2. I have given it. Okay, the cation part. You're starting off with aqua. Sorry, amine. Diamine. Triaqua. Chlorido. Cobalt. 3. And then you write the anion. You have aqua, amine, carbonyl, sulfato, and iodido. First of all, you write amine. Amine, aqua, carbonyl, A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R is. S is coming at the end, right? Okay. I is coming first, so iodido. Iodido, diiodido, ne? Diiodido, sulfato, ferrate, 3. It's like my name. That's a secret, Tifasa. Okay, lamai. Okay, we're moving on. Nomenclature of simple covalent compounds. Right, nomenclature of simple covalent compounds. First part of the name is less electronegative element followed by the more electronegative element. So how do you know Fe3 there? No valence on cation. Yeah, you are knowing that from the valency. Now look at you, this compound. This big thing I will consider M. This big thing I will consider N. So it's Mn2, right? Mn2. So this one should have +2 and this one should have -1, right? So if it is -1, then the total charge of this will be -1. So iodine is -2 altogether. This one is -2 altogether. So altogether these two will form -4 and Fe should be definitely +3 in order to neutralize with -4 and then form -1 on top. Do you understand that? They're null. Okay, right? Okay. Have a 5 minutes break. We'll start at 8:58. Okay, we'll start at 8:58. Maybe we won't do ester nomenclature today. Okay, now I will start now. So we are using prefixes. If there is one, we call it mono. Two, di. Three, tri. Four, tetra. Five, penta. Six, hexa. Seven, hepta. And eight, octa. It won't go that much. Then right there, if one atom is present, if one atom is present, if one atom of first element is present, we don't include it with the prefix mono. We don't write prefix mono if the first atom is 1. For example, sodium chloride, right? Sodium chloride, we don't write the word ionic compound. So let's say NO2. We don't write mononitrogen dioxide. We don't write it like that, right? So with the prefix mono. We don't write it with the prefix mono. But second element must be written with prefix. Second element must be written with the prefix. Right? So you have N2O3 as an example. N2O3, NO2, H2O, carbon monoxide, nitrogen monoxide. Right? So this one is easy. This is dinitrogen, leave a space, trioxide. Dinitrogen trioxide. This is nitrogen. You don't write mono. Nitrogen dioxide. This is dihydrogen monoxide. This is carbon monoxide. This is nitrogen monoxide. Nomenclature of non-oxo acids. So non-oxo acids, right there, starts with hydro, ends with ic. For example, first one HCl, second one HF, third one H2S, fourth one HBr, fifth one HCN. This hydrochloric acid. Chloric. How is hydrochloric? You write. This is hydrofluoric acid. This is dihydrosulfuric acid. This is hydrobromic acid. This is hydrocyanic acid. Hydrocyanic acid. Hi. Write this. Then my nomenclature of oxoacids. Acids containing oxygen are called oxoacids. Then now this one has two types. Now oxidation number lower one, oxidation number higher one. For example, H2SO3. Wait. Right, will you? Right. Right and raise your hands when you're done. Okay, go to the next one. Write this quickly. Can you show the part A? Part A කියන්නේ this one. Megan? I already showed it, right? Now it's fine. Then final lamai nomenclature of oxoacids. Now so we have first one having more than one oxidation number. Having more than one oxidation number. H2SO3, H2SO4. You can write this as sulfurous acid. This one sulfuric acid. Okay, this is not pH, this is F. Sulfuric acid. Then HNO3, HNO2. Nitrous acid, nitric acid. Then right there, second one. We can also name using pH is used in older. Now we are using F. We have to use F in the newer syllabus. In the new syllabus, we have to use F. We can also name the compound with oxidation numbers. For example, H3PO2, H3PO3, H3PO4. So you can name these compounds phosphoric 1 acid. Now phosphorus has +1 oxidation number, right? Correct ne? PO2 3 minus ne? Minus 2 into 2 is -4 +4. Yeah, +1 is the oxidation number. Phosphoric 1 acid. This one is phosphoric 3 acid. This one is phosphoric 4 acid. You can do it for the above two one as well. The methane H2SO3, H2SO4 also you can do the same. Sulfuric 6 acid, sorry, 4 acid. This one also sulfuric 6 acid. So if you are writing the oxidation number, both of them you can write it as sulfuric. +5 yeah, okay, phosphoric 5. Sorry. HNO2 and HNO3 also same. Nitric 3 acid. Nitric, wait, nitric 5, right? This one, nitric 3 is the above one. This is nitric 5. Nitric 5 acid. There you go. That's all, Lamai. That's all the nomenclature you have. Now, full inorganic is covered for 2026 batch. Actually, the full syllabus is covered except for the ester nomenclature and some unit 2 theory points I need to do. Unit 2, certain variations are remaining to do here and there. Your full syllabus is covered within 8 months. So I didn't spill any facts during your revision. Anything I didn't spill, I gave recordings. That's true. For industrial, I gave recordings, and environmental also, I have to give some recordings for you. So yeah, anything you want to know? Yeah, it's in the new syllabus. You have to name esters. Phosphoric 5, yes, phosphoric 5. Oxo acids, can you show? Okay. Yes, so you can leave now. That's all for today. So inorganic nomenclature completed like that. I will send a small video for ester nomenclature. We can't have a class for nomenclature of esters. It's a small section. Maybe like I will send a small video after recording it for the ester nomenclature. So yeah, technically syllabus is complete. Environmental chemistry, the recordings should be sent. So I won't drop a message in the group telling the syllabus is complete because environmental chemistry we have to do and some small sections we have to do. Right. H2S, is it H2S is F. හරිද H2S මං F pH කියලා දැම්මේ. This one also F. I'm sorry, correct it. Sulfuric. Okay, I'll put this in the group. Harry, you can leave the meeting now. Louis Mastery, I'll send the recordings for the rapid revision students.